Okay, let's look at some other types of equations. And by that we just mean some other types of equations that we want to have an understanding of how to approach algebraically. So let's get started. First of all, absolute value equations. All right, so you might remember, excuse me, that like if I had something like the absolute value of x equals 7, that had two solutions. It could be either x equals 7 or x equals -7. All right, and that principle holds true even if we have something kind of weird in the absolute value, or if we have an x or more variables on the right-hand side of the equality, or not inside the absolute value. So let me clear that out. And let's look at this problem. This problem is kind of a more straightforward example. And it says, take the absolute value of x minus 4, and when is that equal to 8? All right, well, I know that this is my approach. I'm going to look at when x minus 4 is equal to positive 8, very similar to the straightforward example that we just had, and then when x minus 4 is equal to -8. All right, so those are my two possibilities. And I'm going to solve both, and this one I'm going to add 4 to both sides, so I get x equals 12, and when x equals, if I add 4 to both sides, -4. Okay, so two solutions there. Now I should very quickly go through and check my solutions. When I plug in 12, I get 12 minus 4 is 8, and so the absolute value of 8 is 8. And then when I plug in -4, I plug in -4 minus 4 is -8, absolute value of -8 is 8. Let's check this graphically real quick. Remember we learned that if we wanted to solve an equation graphically, we could graph the left-hand side and graph the right-hand side and see where they intersect. I think if we do that, we notice right here that here's my absolute value, here's the left-hand side here in red, and here is in yellow, is the right-hand side, or just y equals 8, and notice we have two solutions. And they're the solutions that we found, so I think that makes sense. Let's do another one. Alright, so it works for if I have something kind of weird on the right-hand side also. So if I take the absolute value of x plus 4 equals 5x minus 2, I've got two situations. I've got when x plus 4 equals 5x minus 2, the kind of the standard situation, and then I've also got when x plus 4 equals the negative of 5x minus 2. Okay, so I'll solve the right or the left-hand side one first. X plus 4 equals 5x minus 2, so I'll add 2 to both sides. First of all, I get x plus 6 equals 5x. I'll subtract x from both sides, so I get 6 equals 4x, and then I'll divide by 4. And so I get x equals 3 over 2, or 1.5. All right? Do the same thing on the other side, but I got to be really careful because I have to distribute this negative through the whole thing. All right, so I get x plus 4 equals negative 5x plus 2, and I guess I'll add 5x to both sides, so I'll get 6x plus 4 equals 2, and then I'll subtract 4 from both sides. I'll just do it. So I get negative 2 equals 6x. And then when I divide by 6, I get x equals negative 1/3 when that is simplified, okay? So I've got two solutions, 3/2 and negative 1/3. Well, let's verify this graphically. So if I hit the next slide here, there's the graph of these functions, the right-hand side and the left-hand side, and it looks like there's only one solution here, right here. And it's only the positive solution, which, if I remember right, was 1.5 or 3/2. So this is at x equals 3 over 2. What happened to the other solution? Well, if we plugged in that other solution, that negative 1/3, into here and into here, we would get something that wasn't equal. So for absolute value, so this is not a solution. All right. So for absolute value equations, we always have to go back and check our answers, or check it graphically to see if to make sure that both solutions work, or eliminate the solutions that don't work. Okay. All right, square root functions. So I'm going to approach square root functions very carefully. These are just kind of more complex square root functions. So my first step, you might want to write this down. My first step is to try and get the radical, or the square root expression, by itself. So the first thing I'm going to do is I'm going to add 9 to both sides. And so that'll give me 8 equals 2 times the root of 3x minus 7. And I'm going to divide everything by 2. So that's gone, and I get the square root of 3x minus 7 equals 4. And now I'm going to square both sides to get rid of the radical. And so I get 3x minus 7 equals 16. Add 7 to both sides, I get 3x equals 23. Sorry. And so I get x equals 23 over 3. Okay? So, once again, here's the steps. Make sure that you get the radical by itself first. So I added 9 divided by 2. And then I squared both sides. That gave me 16 on the right. And then just solve the linear equation that's left there, and I get 23 over 3. All right, let's go to the next one. All right, now this next one's really ugly. If I've got 2 square roots, all right, I could square this right now, but it's going to be an ugly, hideous mess, and not that we're not heading towards a mess, but it would be really bad. So my technique is to get 1 square root on one side, 1 on the other side, and then try and square both sides. All right, so I'm going to move this expression here to the right-hand side. So I get the square root of 2x minus 3 is equal to 2 plus the square root of x plus 7. Okay? Now I'm going to try and square both sides. Watch why that's nice. So I'm going to do this in red. So I'm going to square the left. That gives me just 2x minus 3 on the left. Great. I'm going to square the right-hand side. And when I do that, you've got to be really careful. This is not 2 squared plus the square root of 7 squared. This is 2 plus the square root of x plus 7 times 2 plus the square root of x plus 7. All right, now I've got to FOIL that out. And when I do that, I'll leave the left-hand side alone and FOIL the right-hand side. So I'll go 2 times 2 is 4. And then 2 times the square root of x plus 7 is just plus 2 square root of x plus 7. All right, and then plus the inside, which is going to be 2 times the square root of x plus 7. And then times the outside. Now, square root of x plus 7 times the square root of x plus 7 kills the square roots. So I end up with just x plus 7. Okay? It's going to look worse before it gets better. That's all right. So let's change colors now. I'm not really digging the... is white going to work? Oh, that'll work great. I'm not really digging the red there. So let's combine like terms on the right. I get 2x minus 3 is equal to 4 plus 7. So I've got this one here and this one here. So 4 plus 7 is 11. And then I've got just this one x is hanging out over here, so plus x. And then I've got plus 2. 2 squared is 7, well, 2 of those, right? So this is plus 4 square root of x plus 7. Okay? Now, I got to keep going. I'm going to try and solve this the same way I approached the last square root problem, so I'm going to try and get that radical, the square root by itself. So I'm going to subtract x from both sides, and actually to save space in the same step, I'm going to subtract 11 from both sides. Okay, so when I do that, I get just x. Negative 3 minus 11 is negative 14, equal to 4 times the square root of x plus 7. Okay. Next step, trying to get the radical by itself, I'm going to take 4, take both sides and divide it by 4, and that goes away. So I end up with x minus 14 divided by 4 equals the square root of x plus 7. All right, I'm kind of running out of room here. But now, in fact, let's clear some stuff out. Well, we'll move up here. Okay, so now when I square both sides, square the left and the right, on the left, I'm going to get x minus 14 over 4, that whole thing squared, and set that equal to x plus 7. All right, and I forgot the 14. Okay, 14, and then x minus 14 squared is just going to be, you have to trust me on this, x squared minus 28x minus 14 squared. 14 squared, take out my handy dandy calculator here. 196 is equal to x plus 7. Okay, and then don't forget to divide by 4 squared, which is 16. All right, so now we've got a quadratic equation with a denominator, which is kind of ugly. So I'll multiply both sides by 16 to get rid of that. All right, so when I do that, I'm going to end up with, on the left, x squared minus 28x plus 196 equals to, oops, I ran out of room here. Let's just do this up here. X squared minus 28x plus 196 is equal to 16x plus 16 times 7, which is 112. Okay, and then I'll get rid of everything else here. All right, so let's keep working at it here. I'm going to subtract 16x from both sides, so I'll get x squared minus 44x plus 196 equal to 112. Then I'll subtract 112 from both sides, so I get x squared minus 44x, and then 196 minus 112 is 84. And that's equal to 0. Now I've got a quadratic set equal to 0, and I can use whatever techniques I want to solve that x squared minus 44x plus 84. Okay, and this one I'm just going to factor, and I think I'm going to see this. This is equal to x and 42 minus 42, and then plus 2. And I think if you check me on that, oh, excuse me, should be minus 2. That should give me the positive. And you notice then that x equals 2 and x equals 42. All right, and you should check your answers, and I think both answers actually work, so you should be good. X equals 2, x equals 42, and that's it for solving other types of equations.